The legendary attack aircraft will become laser. When the A-10 Warthog enters the battle, all enemies run away in fear because it's the best attack aircraft of all time, equipped with a huge Gatling machine gun. But now its power will increase many times over because instead of a machine gun, it's been equipped with a revolutionary laser system worth $1 million. How did the developers come up with this? Why should an old aircraft be modernized? How quickly will it be able to deal with the enemy? I'll answer all your questions. Sit back and let's get started. The A-10 Warthog is a truly legendary close air support aircraft known for its stability and firepower. This hawk, with its titanium skin and 7-barrel 30mm GAU-8A Avenger machine gun, has repeatedly proven its effectiveness on the battlefield. Just take a look at these videos. Just imagine what it would be like to reinforce this machine with the most advanced weapons and defense systems. This became a reality with the advent of a new laser system worth $1 million. All thanks to the Lockheed Martin Company, which supplied the U.S. Air Force with the first laser weapon to be used on board a fighter jet. And it's called Lance. But is it worth putting a laser on an attack aircraft at all if its machine guns can handle it? Indeed, when it comes to the A-10 Warthog, the first thing that comes to mind is its unrealistic combat capabilities.
We tried to shape an airplane that was directly useful in specifically support of Army troops.
However, even such a powerful aircraft has its limitations, especially in the field of armament. The traditional 30mm GAU-8A Avenger cannon undoubtedly commands respect for its destructive power and ability to fire up to 3,900 rounds per minute. However, to maximize the effectiveness of this weapon, the A-10 is forced to approach targets at dangerously low altitudes, exposing it to particular danger. It can simply be blown up by long-range missiles, and even titanium armor will not help.
It's incredibly accurate for a gun system and probably one of the most flexible weapon systems.
In addition, modern fighter jets are becoming more and more protected and difficult to reach with machine gun ammunition. Even the range of the GAU-8A Avenger is limited to about 4,900 feet, which is currently too short to effectively destroy the enemy. In addition, the aging and wear and tear of the aircraft are also significant factors that reduce the overall efficiency and reliability of the A-10 Warthog. By the way, that's why it was decided to abandon the attack aircraft in general, and only the Warthog was left in service. It's fascinating to see how the United States is trying to rethink the role of the attack aircraft and give a second life to this class of aircraft. Fortunately, modern technology in the form of laser weapons came to the rescue. With the help of the Lance, the A-10 can not only destroy the enemy as effectively, but also defend itself against missiles. It's a 2-in-1 combo menu, and the opponent will definitely not like it. Lance is part of the U.S. Air Force's SHIELD program, and the original idea was to create a defensive weapon, not an offensive one. But the developers have achieved much more. Using new technologies of expanded lenses and energy concentration, they managed to achieve a power of the unit that's almost twice as high as that of analogs. This gave them the idea to combine defensive and offensive capabilities. That's how the modern version of the Lance was born. The new laser's undergone several stages of testing, during which it showed amazing results. 5 targets were hit in 10 seconds. If the minigun installed earlier could fire 3,900 shots per minute, the new laser will increase this figure to 8,000 pulses. This is a real laser machine gun. In just a few seconds, the formidable tank turns into a pile of dust. Each laser shot, heated to 2,000 degrees Fahrenheit, creates miniature explosions on the surface of the equipment that quickly burn through the target. At the same time, the range of fire increases. If previously the attack aircraft had to fly at a very low altitude, taking into account the maximum range of a machine gun shot of 4,900 feet, with the laser, the figure increases to 2 miles. This update will allow the Warthog to stay higher in the security zone and make it out of reach of many enemy defense systems. If the enemy detects the aircraft in advance using radar, it'll be able to use long-range air defense or send its fighters to intercept it. But even in this case, the Lance will do the trick, as it can be used to shoot down even high-speed targets, allowing the attack aircraft to defend itself.
We were able to incorporate systems that had come online, the global positioning satellite systems.
To completely surprise you with facts, the Lance has several targeting heads so it can simultaneously destroy ground and air vehicles and even shoot down missiles flying at the A-10. You have to admit, it's not bad for an old attack aircraft. To illustrate, let's simulate an air battle involving the A-10 Warthog. In many opinions, it'll be opposed by the best modern fighter jet, the F-35 Lightning II. The mission of the attack aircraft is to destroy the convoy of ground vehicles, and the task of the F-35 is to stop it. Write in the comments who you think will win. So our courageous attack aircraft takes off on a mission because the Allies have spotted the approach of enemy vehicles. The A-10 takes off on a mission armed only with the Lance laser machine gun. The target's only 3 miles away, but an enemy F-35 fighter jet has already tracked our hero and is ready to attack it. It fires 2 supersonic AIM-120 missiles, hoping that the attack aircraft has nothing to defend itself with. However, it was not prepared for the fact that the Lance would be able to destroy both missiles simultaneously, despite their speed of 1,860 miles per hour. Unfortunately, the A-10 can't counterattack because the F-35 is much further away from the laser strike zone, and there's no point in chasing it because of the speed difference of 1,180 and 800 miles per hour. In this case, only one thing remains. The Warthog is heading for the column of tanks despite the attacks from the F-35. The enemy pilot sees this and tries to fire his entire arsenal of weapons, but each of his missiles explodes in midair before reaching the target. The F-35 is helpless against the A-10's defense, and the latter, in turn, calmly fires to the tanks, and switching the laser to attack mode blows all the equipment to pieces, leaving only molten metal to cool. This is a short and clear description that shows the true power of a laser attack aircraft. It can go for the breakthrough, destroying its targets, because it's not afraid of its opponents. Perhaps the only thing that can counteract this is the same kind of attack aircraft, but literally all countries have abandoned them. As you can see, the implementation of the new laser system in the A-10 Warthog represents a significant step in the development of the Air Force. This advanced technology not only enhances the firepower of the aircraft by replacing outdated systems with more accurate and efficient laser weapons, but also expands its combat capabilities.
We were able to go places that the other fixed-wing assets may or may not have been able to get in very well. And we definitely went places that the helicopters couldn't get in.
The advantages of the Lance include an increased ability to cope with modern air defense systems and maneuverable air targets, as well as the ability to protect against missile attacks. This makes the A-10 Warthog not only an offensive, but also a defensive weapon. In the future, the integration of the laser system into the A-10 will change the strategic landscape of air warfare, ensuring high survivability and effectiveness in modern combat operations. Moreover, lasers do not need any ammunition at all. They only need energy, and one shot costs $3, which is even more cost-effective than any other weapon. Thus, the integration of the laser into the A-10 Warthog is a breakthrough solution that's expected to change the world of combat aviation. The idea of laser weapons came to the military from the entertainment industry. With the advent of the first developments in the 60s, comic book and movie creators showed colorful blaster shots, lightsabers, and other weapons that seemed universal and stirred the imagination of military engineers. The first practical attempts to use lasers as an independent type of weapon took place in the early 2000s and looked like a laser installation attached to the bow of a Boeing 747. This set the development vector for what we see now. Israel's making great progress and is even getting paid for it. The United States has announced that it'll provide Israel with $1.2 billion for laser weapons under the Iron Beam program.
When you push the button, your beam touches the rocket at the speed of light.
Why is this so? It's simple. Such investments will save money for the United States itself. High-energy laser weapons offer a significant economic advantage. Each shot costs up to $1,000, in contrast to the estimated cost of the Tamir interceptor missile used in the Iron Dome missile defense system, which costs between $40,000 and $50,000.
I would say around 90% of the interceptions we wanted to make, we make, but still there's too many rockets raining down here.
Initially, the laser system was planned to be adopted by the IDF in 2025. However, the current situation calls for the process to be accelerated. In 2022, Israeli Prime Minister Naftali Bennett announced the country's plan to create a laser wall to to move from spending money on a large number of interceptors to using less expensive lasers.
I'd say there are two advantages. One, the cost per kill, the recurrent is low. And the second is that there is no ammunition.
And in April 2022, the Mag and Ore system successfully intercepted mines, missiles, and anti-tank missiles during tests in the Negev Desert. In February 2023, the Iron Beam project, which includes Mag and Ore, was presented at the IDEX Defense Exhibition in the United Arab Emirates. However, Israeli experts emphasize the technological difficulties that lasers face when dealing with large missile volleys, as lasers need time to heat up the target and destroy it. For example, to destroy a missile, a laser may need to hit the target continuously for 2 to 3 seconds. In addition, the Iron Beam is not immune to the general problems inherent in laser weapons.
The disadvantage. One is a short range, the other is the sensitivity to weather, and the third is the low kill rate.
The war between Israel and Hamas has shown that the militants have potentially doubled the rate of missile fire compared to the war they fought in May 2021, and the speed and range are critical.
The range is limited. It's more limited than the range of interceptor weapon.
And not only Israel faced this problem, continuous attacks on U.S. bases in Iraq led to the deployment of the first operational laser weapon system. 3 Stryker armored fighting vehicles armed with 50-kilowatt lasers known as DM SHORADs are already countering drones that have caused losses to the U.S. military. The DM SHORADs is intended to provide air defense for ground forces, protecting them from drones. The entire 50-kilowatt laser system weighs about 7 tons, and when mounted on a Stryker, it receives armored protection and a maximum speed of 62 miles per hour. The system is controlled by a secure laptop, and the operator uses an Xbox-style controller to control the fire. The use of lasers has several advantages over existing drone countermeasures. Unlike gun or missile systems, a laser theoretically has an unlimited number of shots, limited only by the access of the system to electricity. The lasers travel at the speed of light and do not require guidance to intercept a target. The system will also not suffer from electronic warfare interference. The DM SHORAD systems are not only capable of engaging drones, but also capable of destroying enemy shells in flight. This is the first ever system capable of intercepting enemy artillery shells in the air before they hit the ground. Compared to the Israeli laser, this one looks a bit more advanced and sophisticated. However, not everything is so perfect as well. Substances in the atmosphere, especially water vapor, as well as sand, dust, salt particles, smoke, and other air pollutants absorb and scatter light, and atmospheric turbulence can defocus the laser beam. While work is ongoing to improve land-based technologies, surface lasers are already actively performing combat missions. Shipboard lasers such as the 60-kilowatt Helios with an integrated optical occluder and surveillance system can significantly reduce the impact of atmospheric water vapor on laser performance by operating only at hot spots in the electromagnetic spectrum. But other phenomena, such as dust storms, do not yet have such a convenient solution. Although where dust storms come from in the sea is a matter of debate. Currently, the U.S. Navy has 1 San Antonio-class amphibious transport ship equipped with a 150-kilowatt Mk2 Mod 0 laser weapon demonstrator. 8 Arleigh-Burke-class destroyers are also equipped with the Odin optical dazzle system, and 1 Arleigh-Burke-class destroyer is equipped with the well-known 60-kilowatt high-energy laser with the Helios integrated optical dazzle and surveillance system. Some of these systems are already in active use and are helping to repel attacks in the Middle East, which significantly reduces the cost of air defense. However, the United States always wants more and is actively working on a powerful 300-kilowatt Hellcat laser. It differs from previous systems in that it will engage not only UAVs but also anti-ship cruise missiles. The U.S. Navy initiated Hellcat in 2019 after completing the first phase of the ruggedized high-energy laser program. The main purpose of Hellcat is to serve as a building block for future programs by solving technical problems. The effort to build and develop technology through separate programs designed to meet specific technology challenges will culminate when these program elements are combined into the laser weapons testbed that's central to the Hellcat. The basis of the test prototype of the laser weapon will be a 300-plus kilowatt laser.
That is a fundamental change for laser weapon systems, which here to date have been prototypes
After the completion of testing of the main components and subsystems, the Navy will begin testing the system against targets of increasing complexity. At the initial stage, the system will be tested on static ground targets, then on dynamic targets, and then move on to intercepting low-cost unmanned aerial vehicles and cruise missiles. Israel has not reached such a level yet, but who knows what $1.2 billion can do. However, in the laser world, the United States and Israel have another competitor, or should I say ally, who's also ready to revolutionize the world of weapons. The UK has demonstrated a new laser weapon that the military says can provide effective missile or air defense at a cost of about $13 per shot.
So Dragonfire's laser-directed energy weapon demonstrator.
A recently released video from a test of what the UK Ministry of Defence calls Dragonfire, a directed energy laser weapon system, captured the successful use of a laser against an airborne target. It's potentially a game changer for air defense, says the video, which shows a bright laser beam piercing the night sky over a training range in the remote Hebrides archipelago, creating a ball of light when it hits its target. The British Ministry of Defence claims that Dragonfire can accurately hit a coin-sized target at long distances, but does not provide specifics. The exact range of the weapon is classified.
Which we can just fire using a laser weapon and have on our platforms is potentially going to be much cheaper.
The laser beam can cut through metal, leading to structural failure or more destructive consequences. It's also claimed to destroy targets at a fraction of the cost of modern air defense missiles. The Ministry of Defense has estimated the cost of a 10-second laser shot at about $13. For comparison, a standard missile used by the U.S. Navy for air defense costs more than $2 million. And perhaps this weapon has already been used in combat, because Dragonfire's participation in repelling Iranian attacks on Israel and protecting the Red Sea is being actively discussed by experts. And something tells me that this is true.
And is at the leading edge, not just of technology, but in demonstrating the end-to-end capability and inform the UK's future procurement.
Given the current pace of development of laser technology, in a few years, we'll see the massive use of these systems and the gradual retreat of air defense systems into the background. And we hope that by the time these weapons will not fall into the hands of crazed dictators. Thank you for watching, and see you soon.